Good afternoon, everyone, and thank you for joining us for today's webinar. We are going to get started here in just a few minutes, but before we do, I would like to go over a few housekeeping items with those of you that have come into the room. For those of you that we have already joined us, the first thing I would like to make mention of is our chat pod, which is located on the left-hand side of your screen marked chat. This chat pod will be the best way to communicate with us should you have any questions regarding today's material. All questions pertaining to the material will be retained until the Q&A session that will be held at the very end of today's webinar. So please feel free at any point of today's discussion through either one of our presenters' presentations to please go ahead and type in your questions there in the chat pod, and either myself or one of our customer service representatives will make sure to get you taken care of. All of your audio for today's webinar is going to be streaming through your computer speakers. So if at any point of today's live event you do happen to either lose your live audio or live video feed, the first thing we would recommend you do to troubleshoot is simply refresh your web browser and then hit the play button again that will be in the middle or on the bottom right of your live feed window. This should refresh your live feed connection as well as your live audio connection to today's event. If for some reason this does not troubleshoot your issues or you experience any other technical issues, again, you can let us know in the chat pod, or we have our toll-free number as well as our email address that are located directly above today's live feed window. You will also see at the bottom of the live feed, we do have our closed captions that are running there now. So they will also be running throughout the entirety of today's presentation. So if at any point of today's talk you would like to follow along with our closed captions, you can feel free to do so there at the bottom. We've got about 6 or 7 minutes before we get started. I'm going to mute my line back and I'll come on once more to go through housekeeping with those participants that do come in over the next few minutes. But for those of you that we do already have in the room, I would like if you can take a few moments to go ahead and type in your location there in the chat pod. That'll give us some great information and feedback about our audience, as well as where everyone is joining us from today. Also, the best web browsers to use for today's event are either Mozilla Firefox or Google Chrome. If you do not have Mozilla Firefox, we want to make sure that you do have the best webinar experience possible. So if you do have the capabilities to do so, please make sure to use one of those web browsers for today's event. Again, it is 6 minutes before the top of the hour. I'm going to mute my line back for now, and I'll come on once more before we get started. Thank you for joining us. Good afternoon, everyone, and thank you for joining us for today's webinar. We are going to get started here in just a couple of minutes, but before we do, I would like to go over a few housekeeping items with those of you that have come into the room. For those of you that we have already have joined us, the first thing I would like to make mention of is our chat pod, which is located on the left-hand side of your screen marked chat. This chat pod will be the best way to communicate with us should you have any questions regarding today's material. All questions pertaining to the material will be retained until the Q&A session that will be held at the very end of today's webinar. So please feel free at any point of today's discussion, if you do have a question, to go ahead and type them in there in the chat pod, and I will pull them out and hold them for our Q&A session that will be held after both presenters are finished with their presentation today. Also, today's webinar will be streaming through your computer speakers. So if at any point you have any technical issues with your audio, please feel free to let us know in the live or in the chat pod, and we can make sure to get you troubleshooted properly. If for some reason you do lose your live audio or your live video feed, the first thing we would like to have you do to troubleshoot is simply refresh your web browser and then hit the play button on the live feed window again. This should refresh your both live audio and video feeds for today's event. If you're not able to find the play button on your live feed, then you might need to make your live feed window full screen. On some browsers or some views, it might be hidden, so you might have to hit the full screen button, which is located on the bottom right hand corner of your live feed window. That will open it up and it should give you your play button there. You will also notice that below our live feed window, we do have our closed captions that will be running throughout the entirety of today's event, should you want to follow along there. To make sure that our audience is experiencing the best possible webinar today, we do recommend that you utilize either Google Chrome or Mozilla Firefox as your web browser, as both of those have been shown to give the best performance for our webinar platform. It is almost the top of the hour, so I'm going to mute my line back. I'm going to change up a few things on my end, and then we're going to get started here momentarily. I've seen quite a few of you type in your locations there in the chat pod. If you have not, if you could please go ahead and type in where you are joining us from today. That'll give us some fantastic feedback about our audience. We have quite a few from all over the United States. I also saw someone from the UK in Wolverhampton. Go Wolves. So it is great to have an international presence as well. It is the top of the hour. Again, I'm going to switch some things on my end, and then we will get started here momentarily. Thank you for joining us today. Good afternoon, everyone, and thank you for joining us for today's webinar. My name is Josh Vickers, and I am with RTI International's Forensic Technology Center of Excellence. Today's webinar is entitled Testing the Accuracy and Reliability of Palmar Friction Ridge Comparisons, a Black Box Study. We have two subject matter experts for today's event. Our first presenter is Ms. Heidi Eldridge. She's a latent print examiner for over 12 years. She is a CLPE and Board of Directors member with the IAI and sits on the JFI editorial board and was an original member of the Friction Ridge subcommittee of the OSAC, where she is now an affiliate. Heidi has been teaching latent print testimony for over 9 years and is a PhD candidate in forensic science at the University of Lausanne. After 11 years as a practitioner, she is now a research forensic scientist at RTI International, involved in research to strengthen the foundations of the latent print discipline. Our second presenter of the day is Mr. Christophe Champol. He's a professor at the School of Criminal Justice of the University of Lausanne. He is in charge of education and research on identification methods and has the privilege of working with a group of 20 PhD students. His group's main interests center on considering inferential aspects associated with forensic identification techniques to assign value to forensic evidence. He's also a steering committee member for the International Fingerprint Research Group and an invited member of the Friction Ridge Subcommittee of the Organization of the Scientific Area Committees, or OSAC. He has received both the Distinguished ENFSI Scientist Award and the Henry Medal Award for his contributions to forensic science. Just a quick disclaimer before we do get started. The opinions, findings, and conclusions or recommendations expressed in this presentation are those of the presenters and do not necessarily reflect those of the Department of Justice. Any products and manufacturers discussed are presented for informational purposes only and do not constitute product approval or endorsement by the U.S. Department of Justice. And now, without any further ado, I would like to hand the microphone and platform over to our first presenter of the day, Ms. Heidi Eldridge. Heidi? Heidi, your microphone might be muted. Let's see.
Now can you hear me?
Yes, ma'am. You are good to go.
For some reason, as soon as I took over control, I lost control of my microphone. Okay, thank you everyone for attending. This is Heidi Eldridge, as was noted, and thank you for the introduction, Josh. Just so the listeners are aware, Christophe Champeau and I worked on this project together along with Marco Dodano, who is also actually in the room with Christophe at the moment. And we had some help from some other research assistants. I will be presenting the first part of this talk. I'm going to walk you all through some of the sort of basic findings of the study, and then I'm going to hand it over to Christophe midway through, and he's going to tackle some of the more advanced, interesting stuff and also give you guys a live demonstration of 2 online applications we developed that will allow any of you to go on the web and play around with our data. So that's sort of the plan. And then, of course, we'll take questions at the end. So let's see if I can get myself advancing here. Whoops. All right. So getting into why we did this research in the first place. I'm sure many of you are familiar with the black box study, as it's usually known, which was the study done by the FBI and Nobles to establish a baseline error rate estimate for the fingerprint comparison discipline. And that was a very well-regarded study that's been cited a whole lot, and I think we all rely on pretty regularly. In that study, they did report a pretty low false positive rate, 0.1%, and a pretty high false negative rate, around 7.5%. But that study only focused on finger marks. In other words, the prints at the tips of your fingers. It did not look at joints, and it did not look at palms, and it did not look at feet. So while we could claim that we have now a discipline-wide error rate estimate for fingerprint comparisons, we really had no way to say anything meaningful about any other friction-ridge comparisons. We don't really have anything in the literature that would lead us to believe that palms would or would not be equally easy to compare or have similar accuracy rates to those finger comparisons. And anecdotally, when you talk to people working in various labs around the country, around the world, the number seems to settle in at about 30%. People tend to say, you know, about 30% of my casework involves palms. So it would be useful to know whether we're as accurate at comparing palms as we are at comparing fingers. So this is the problem that we were tackling with this research. We wanted to try to establish a similar error rate for palms as what the FBI Nobles study did for fingers. So in order to do that, we needed to establish a ground truth data set. In other words, we needed to have a series of marks and prints where we had absolute knowledge of where they originated so that we knew if people's determinations were correct or not. So in order to do this, we collected palm marks from known sources. We had 6 different forensic laboratories who were helping us with this, collecting images within their labs and then sending them to us. And in that process, we ended up with more than 500 marks that we had corresponding inked prints for, either same source or different source. The methods that our partners used to produce these marks ranged widely. We asked them to use sort of standard development techniques, and we asked them to use sort of standard or a variety of application methods. We wanted a real range that was representative of what these marks look like in casework. And they really took up that charge. They got very creative with their production of the marks. We got marks in blood, we got marks in sweat and sebum. I got a few in barbecue sauce. So we had a very wide range. And once we had all of our marks selected that we were going to use in the study, we took 120 of those marks and we searched them in a palm APHIS system that had a background population of about 25,000 palm print cards. And because we wanted to generate close non-matches that we could use to make challenging different source comparisons. Obviously, we wouldn't have a very accurate error rate if every different source trial was obviously a different source. So we were looking for the closest ones we could find. And we did this in two different ways. For each mark that we searched, we brought back both the candidate who was the number one APHIS candidate, in other words, the one that APHIS thought looked the closest. And then we also had our research assistant go through and manually decide which one they thought visually looked the closest. So for each of these marks, these 120 marks, we had two different APHIS candidates that we could use as different source trials. So the study was administered using Pianos. Pianos is a custom software interface that can be used in a web browser that was developed by University of Lausanne. And it was customized for this particular study to have all of the tools that we needed. And in Pianos, we had 526 different cases. Again, some are same source, some are different source. And we broke those out into groups of 75. So each participant who signed up for the study received a batch of 75 cases that they were asked to complete. Some people managed to complete all 75. Some people completed one. We had the full range, but we used all of the data that we collected. So if somebody was only able to complete 2 or 3 trials, we still took the data from those 2 or 3 trials. In all, we had 226 fingerprint examiners who completed at least one trial. And so they're included in these data. And we ended up with over 12,000 analysis determinations and over 9,000 comparison determinations. Now, when we did our data analyses to determine false positive and false negative rates, we removed the inconclusive determinations from that calculus. We only determined the error rate using identification and exclusion decisions. So when you remove those inconclusives, that's how we get down to that 7,620 number. We had 7,620 decisions that were either identification or exclusion that could be compared to ground truth. On average, each case was viewed by about 23 examiners. So this first image I'm showing you is actually the results from the analysis phase only. This is not a comparison result. This is just did people say it was suitable or not suitable. And you'll see that at the bottom there on the x-axis, we've labeled this as ground truth by proxy as voted by the majority. The reason we've done that is because obviously for the suitability decision, there's no such thing as ground truth, right? It's a subjective personal decision. There's no way of saying that any particular person is right or wrong. So in order to be able to see where our agreement lie and where people had differences, we took the majority vote and said, okay, that's ground truth for the suitability of this mark. So what you're seeing again along the x-axis are the ground truth majority votes, and what you're seeing along the y-axis are what individual people decided. And the 2 red boxes are where we have lots of disagreement. So you'll see the number 788. Those are cases where the majority voted that a mark was suitable for identification, but 788 times some individual said, nope, that's no value. The 599 is the opposite. These are ones where the majority said that mark is not a value, but 599 times somebody said, I would ID that. And you can see also from the right column that we have zeros all the way in that right column, meaning that suitable for exclusion only was never the consensus decision for any of the marks in our study, which mostly just tends to show that there aren't that many laboratories using suitable for exclusion only, in that it was never the most voted option. This goes into the analysis data just a little bit deeper, and this is a sample. This is not all of our data. If we put all of our data here, there would be too much. It'd be really hard to see. So what we did was we just took out 40 cases that had at least 10 people view them. And what you're seeing is the top bar there is all of the no value as voted by majority. So these are the marks that most people thought were no value. And the bottom is the ones that most people thought were of value for identification. What we want you to take from this slide is the amount of variability that we're really seeing between examiners. So if you look at that top bar, the no value as voted by majority, we would expect every one of those bars to be solid red or close to solid red, right? If people were agreeing with each other, those should all just say no value. But you can see that there are a lot of different colors happening there, a lot of places where people had different opinions. And the same goes for the bottom bar. We would expect those to all be solid green if everybody was agreeing on what is value for identification. But we don't see that. We see a fair bit of no value and value for exclusion only decisions creeping in there. Okay, so now we get to the results that everybody gets really excited about, which is the ground truth comparison results. So again, these are the cases where we removed inconclusive. You'll see that the only choices in our confusion matrix there are identification versus exclusion. Inconclusive is not represented. When we remove the inconclusives, we end up with a false positive rate of 0.7% and a false negative rate of 9.5%. You'll notice that we got there by having 12 false identifications and 552 false exclusions. So these numbers are higher than the numbers that were reported by the FBI Nobles in their fingerprint study. You'll see that the false positive rate is about 7 times higher. The false negative rate, they reported 7.5% and we're reporting 9.5%. So we're 2.5% higher, which might sound like bad news on the surface. I'm actually taking it as really good news. I expected that false negative rate to be much higher. I expected it to be at least double what FBI Nobles reported. And that's for several reasons. One is because palms are just inherently easier to miss. There's a lot more space to cover. There's often a lot less orientation information available. We get less training on palms. Examiners just don't have as much practice with them. And then added on to that is the fact that we were a little bit nasty in our design, and we did not necessarily present the latent in the correct orientation. There was a rotation tool, and participants were able to rotate that mark around, but if they did not do that, they might have been looking at it upside down or sideways or in some incorrect orientation. The FBI Nobles study did not have that element. Theirs were all presented in the correct orientation. So there was an extra element of difficulty in our study. So the fact that the false negative rate was only 2% higher is actually sort of encouraging. And then if you look down in the lower right-hand corner, you'll see that we took the false positive and false negative rates and we stratified them according to the difficulty of the comparison, whether it was easy, moderate, or difficult. And those determinations were made by me, the difficulty of the comparison. But you'll see that they behave very much the way we would expect them to. The false positive and false negative rates both increase as the difficulty of the comparison increases. This is one more way of looking at the performance of the examiners. In this graph, we're showing you, again, not all of the examiners because the data would become very messy, but this is 170 participants who submitted at least 15 comparisons. So the people who did 2 or 3 comparisons aren't in here. But what you're looking at is individual performance. Each one of these little balls represents a single participant. And what you'll see is there are a whole lot of little green balls lined up vertically at 0. That's a good thing. That means that those are all the people who made 0 false identifications. The yellow balls and the red balls that are streaming out to the right are the people who made false positive errors. So they're spread out along the false positive rate axis, the x-axis. So you'll see that while we reported 12 false positive errors, those came from 8 people. We had 4 people who made 1 error each, and we had 4 people who made 2 errors each. Now, if you're wondering why those aren't lined up nicely the way the green ones are, it's because this is a rate, which means that it's some number out of some other number. And because, as I mentioned, not every person who took the study completed the study, that means that people had different numbers of comparisons. So their rates are going to be different because they have different denominators. So even though all the yellow people made the same number of errors, they did a different number of trials. That's why they're spread out a little bit. So the farther right you are, the less accurate you are along false positive. In other words, if you're far to the right, that means that out of the number of trials you did, a larger number of them was incorrect. Now, on going up the y-axis, looking at all these greens, they're sort of spread out for the same reason. Even though they didn't have any false positive errors, lots of people made lots of false negative errors. Remember, we had 552 errors, 9.5% error rate overall. So these individuals, particularly the one at the top there, that person, for how many trials they did, made a lot of false negative errors. So you want to be down at the lower left corner. That means you're super accurate. These two dotted lines that are going across the middle, the 95% and the 90%, are showing how an examiner did in relation to other examiners in the study. So below that 90% line, that's saying 90% of the users have a false negative rate that's below 31%. And then the next one is below 44%. You can think of these sort of like the results you get when you took your SAT exam. Remember, you got back your score and then you had your little percentile rank. And that percentile rank said, okay, if you're in the 95th percentile, that means that you did better than 95% of the other people who took the test. That's kind of what this is showing. And Christoph will show you later what this interface looks like online. You can actually go to this full chart online. And if you touch any of the balls, it will tell you the user name. So if you took part in this study and you know your username, you can find your own little ball and you can see where you are in relation to other people. Okay, so these are the comparison results for the majority vote. Remember, before we were comparing to ground truth. Why would we want to talk about majority vote? Why would we care about majority vote? Well, because in the real world, we don't know the ground truth. We use the ground truth to do these studies, but when you're making decisions in the laboratory, you're kind of basing those decisions on majority vote, aren't you? Because you give your decision and then you hand it off to somebody else for verification, and that person may or may not agree with you. And if they don't agree with you, it might go to a consensus panel, and you're going to find out if those people agree with you or not. And eventually you're going to report something out. Well, that's kind of a majority vote process. And so it's really interesting to look here and say, okay, what if we didn't know ground truth? What if we just took ground truth as being what the consensus body came up with? Then how often would we see false positives and false negatives? And that's what these numbers reflect. And you'll see that inconclusive is included here. And you'll see that the false positive number has jumped considerably. It used to be only 12, and now it's 45. Well, obviously, ground truth didn't change. The people didn't suddenly get it wrong. But what this means, the reason that this number is so much higher, is because there are instances where the majority got it wrong. In other words, the majority decided exclusion, and ground truth and what this person stated correctly was identification. So really what those extra supposed false positives represent are situations where in the real world, the initial examiner who said ID would not be believed by their peers, right? They would be told, no, you're wrong. This is an exclusion. So it's something that bears keeping in mind, that just because the consensus decided something doesn't necessarily mean that they're correct. This is showing a little bit more the data from the previous slide. These are all of those cases in which the majority decided exclusion, but the ground truth was same source. And you'll see for a couple of these, it's not that big a deal. For instance, image 368 there is mostly gray. That means most people said it was no value. One person falsely excluded it. So technically the majority was a false exclusion, but that one doesn't really have real world consequences. If you look, however, all the way to the right at case 423, you'll see that the votes are almost evenly split between false exclusions, inconclusives, and correct IDs. That would be a hard one to resolve in casework. And then there are some like case 53 at the left, where most people said false exclusion, and there were only 2 people who correctly identified it. So those 2 people might be in trouble at their laboratory, and they were right. So it's something to bear in mind. This is just a quick little chart that shows you what the 12 false identifications look like. So these were the 12 cases in which we had a false ID. You'll notice they are all different cases, meaning at no point did the same pair have a false ID declared by 2 different people. They were all individual circumstances. And again, just have a look at the general variety in responses here, the variability between examiners. You can see that there's no pattern here where everybody agreed on one thing and just one guy got it wrong. There's sort of a variety between the different conclusions that were selected here. Okay, I'm running low on my time, so I'm going to move quickly through these examples so we can get to Christoph. But I did want to show you guys some quick examples of some false positives and false negatives we got. Because this was a black box study, nobody was required to give us notes. They weren't required to let us into their thought process, but some people did. Some people chose to share, and that was really helpful in allowing us to reconstruct some of the errors that we did see. So this is one of the 12 false identifications. Because of privacy issues, we can't show the exemplar in this case. So you're looking at 2 copies of the mark of the unknown side by side, and both of those are with this participant's annotations. But the reason we showed it this way is because you can really tell, especially with their written notes, what went wrong here. If you can see that the green line that they drew, that's sort of up at the upper left quadrant of the image, they told us in their written notes that outside of that green line was a different impression, and that outside of the green line impression was not an ID, but that inside the green line, it was an ID. First of all, this is the same impression. These were all laid down singly. But if you look at the quality of the mark inside the green line versus outside the green line, it's not great anywhere. But inside the green line is much worse. And you'll notice that all of the minutiae that they marked in the right-hand image are yellow. And in pianos, yellow minutiae means it was marked after the exemplar was seen. So this person marked all of their minutiae after they had seen the exemplar and then made an identification based on only the worst part of the impression. So it's a little bit easy to see how that bad decision was reached. For both erroneous identifications and erroneous exclusions, we were not able to link or predict the rate based on the demographics or anything about the participants. So there was no red flag that, these people who have this much experience or are certified or not or whatever are the ones who are going to make the errors. So I'm going to just walk you quickly through this erroneous exclusion. This is the mark as it was presented in the study. And in the lower left there, you see how the item was handled to produce that mark. And this is the exemplar that they were given. And you can see the annotations that the participant made. They did a pretty good job annotating. You can see that they have this little orange cat whiskers, I call it, this little cute feature that's very distinctive. And these are their written notes at both analysis and comparison. And you can see that in both places, they specifically mention the curved edge and that they think it's the bottom of a palm. And you can see where they annotated, clearly this is where they were comparing. This is where they were hoping to find their mark, and they failed to find it, and so they excluded. This is the correct area where the latent or the mark originally came from. And you can see the area that I've highlighted pink. That's actually their little orange cat whiskers. They did record reliably. They were present in the exemplar. They just failed to find it. And you can see how easily they failed to find it because they were locked into this notion that it had to be the bottom of the palm. And the shape does lead one to believe that, but you can see from the way it was placed how that curved shape could be produced by a different area of the palm. And now I'm going to hand over to Christoph.
Thank you, Heidi, and good evening to everyone, because it's almost 6 o'clock here in Switzerland, and me and Marco are delighted to be on board. I give you a few seconds to get accustomed to my Swiss accent, because it's quite different from Heidi's. What I'd like to do with you is to take you through what we have done in terms of machine learning on these data, and that's one aspect. And the second aspect is to show you the apps that we have developed with the team in order for you to access to all the information that was presented up to now. But a quick information regarding what we tried to do with machine learning. Everything that was presented up to now is related to experts' decisions on images. Expert decisions which are made on a series of factors, and of course one of them is probably the perceived quality of the image and the number of minutiae, which led them to assign that mark to the bin value for ident, for example. And here I'm talking only about analysis. So what we tried as well is to see if we could somehow provide user-independent measures to classify these marks. So we took advantage of quality metrics, and 3 quality metrics were tested. They are named LFIQ1 and LFIQ2, and these 2 have been designed by Michigan State University and published in 2012 and 2013. And we have used the set of quality metrics called LQ metrics, which are embedded in ULW and have been developed by the FBI Noblis initiative. So all of the marks in that study were measured according to metrics. And our objective was to see if by machine learning, we could predict the outcome of the class that should be assigned to each mark. Now, as Heidi mentioned, when it comes to analysis, whether you will declare a mark being value for ident or of no value, there is no grand truth known today which could make that assignment, contrary to what you have for comparison. So the grand truth was obtained by proxy, by declaring that the most voted class will be the class that mark should be assigned to. So what we are trying to do is we take the images and their quality metrics, which will act as potential predictors for the class which have been assigned by the majority vote by the examiners who took the study. Now, does it work? Well, the next slide will give you the. I need to switch to and I beg your pardon because I forgot to share my screen instead of sharing Heidi's screen. So I just do a quick switch to mine. Here we go. So does it work? The answer is yes, it does. And we have tested a range of classifier, separating half of the data to do the training and half the data to do the testing. And this is the best classifier called GBM, which led us to an accuracy of 87%. Now, if you look at the graph, and I take you through it for a second, this group here on the left, so this one is the cases that have been voted no value by majority. And that group is the cases, the marks that have been voted VID or value for identification by the majority. So this is the grand truth state. And the colors tell you what the machine learning classifier decided. So in red, you have no value, and in bluish, you have a value for identification. And if you look at the dots, they are arranged on the y-axis according to one of the metrics. So we have used LFIQ2 to scatter the point. The higher the value is, the better the mark is in terms of the answer of the algorithm. The lower the value is, the less quality the mark is declared to be. So you can immediately see that when you have good quality marks, according to the algorithm, the classifier, we have no difficulty to put them in the bin VID. But when the mark is of lower quality, which is reflected by being low in terms of LFIQ2, then you have more peppered point, meaning that the classifier has much more difficulty to decide for you whether it will be no value or value for ID. So we felt it's important to explore this because on one hand, we can realize that examiners may have some error rates associated with these decisions, but also machine systems will also have an error rate associated with these decisions. It's working fine. You have quite high accuracy, but high accuracy is especially obtained on good quality marks. These marks normally will not be suffer from a lot of errors from examiners. But as soon as the quality drops, there is more difficulty, and that's exactly the same for the human examiner. We will have more differences between examiners when we have marks of low quality. Now I'd like to take you through two little apps, and I leave the URL for a second. The project, all the results of the project will be presented in two applications, and I will do a live demo in a second. The first line is the URL to access to the results of the study. If you are a user who have been enrolled, you will find your results on that URL, on that website. The second app, and I will spend probably today a bit less time on it, it is an app which has been specifically designed to compute confidence intervals. So if you make an observation of a given error rate, very quickly statistician will look at you and ask, well, what is the confidence interval around that proportion? So we designed an app, a specific app to compute, according to various techniques, statistical techniques, the credible or confidence intervals that needs to follow an estimate of proportion. So the first app is in relation to the results, and there is some statistical figures which come directly from the study. The second app is entirely based on the study results with the addition of the confidence interval. So I move to the first application first. First thing first, as I said, and these are the overall results of the study. If you had the time to go on the website, the link, you should end up exactly on that little application. Heidi showed you that all examiners who took the study can be presented in one graph, and that is the graph that Heidi showed you. And one of the beauty of having a web interface is that it is more living than static. So if you want to know, if you go on the little dots, you can know what is the user. So here we know it is user 132, and we have the false positive rate and the false negative rate, and there is an additional information saying that that person made 2 false identification. So you can go through each of these people one after the other. I close this one because I want maybe to take the position of what could be one of you, and I take at random one user. If you scroll down on user 20 and you have all the users, these will be the results of user 20. So you will have a presentation of that user, and you can compare. If you go to compare, you can compare user 20 against all the others. So there is a little arrow showing where is user 20 and how are the others. And of course, if you want just to go to someone of interest, and of course we are maybe interested in that individual who has 2 false identification, if you double click on it, it will take you directly to that user 290, and the matrix of error. So going from compare, you can switch to users, move from one user to the other very easily to explore the data. The matrix, there is 3 different options, and you have seen them in the presentation of Heidi. One is comparison against grand truth. So it's a 2x2 matrix. That's the 2 wrong identification declared by the user. These are the 5 wrong exclusion declared by the users. The little boxes below are just to highlight what it means from the table. There is no new information that you cannot derive directly from the matrix, except this green box telling you whether the examiner did all the comparisons that were given to him or her. The app will give you the error rates which are computed. It means that these numbers are user specific. So that examiner has a very high false positive rate of 25%. Another examiner will have a different profile. So the app will compute the error rates user by user. Now, another way of looking at the data is to compare against the votes, and that is a 3x3 matrix where you can see the inconclusive decisions, and whether or not it is the right decision is made against the voted majority. So at some point we'll hit the point where people have made, and Heidi alluded to, have made the right decision when it comes to the grand truth, but it is counted as the wrong decision in that angle because the majority of the examiners who took that case decided otherwise. But you have exactly the same type of results. The only difference is that the computation of the error rate is a bit more difficult for a 3x3 matrix, so you have more information displayed, but essentially it is the same way. And there is a small help tour that you can take if you are completely lost in this app. And the last one is the analysis results. I could have started from there, but I think it's more interesting to start from comparison and rolling back. So this is for this user. You could see that against the decisions made by the majority, he has made three, he called 3 marks to be VID, where in fact it was declared as no value by the majority. So you can see some profile of decision makers, some risk takers, some risk adverse in their decision-making process. And as we have seen in the compare, not all examiners are equal. And they do vary both in terms of false positive. These 4 examiners have made 1 false identification. These 4 examiners have made 2 false identification. All the greens examiners have made no false identification, but they do vary quite substantially in terms of false negative. So the number, if I go to this one, the number of wrong exclusion can be quite high. Heidi mentioned that sometimes examiners have not carried out all comparisons, so it means that the number will reflect that and the rates will be reflected accordingly. So this is the number side, but it's quite nice to see, instead of seeing numbers, is to see graphs. And the graphs that you have seen, I go back to my user 20 as before, the graph you have seen can be shown directly. So if you are user 20, you click on the graphical overview, and these are the results of all the cases that you have done. You can zoom on these cases, and you can also look at everybody else. So I just zoom on these cases of different sources. So that user did these exercise. He didn't do any false identification, but you can see that this is one user, user 290, who did a wrong identification, and this is another user, 194, who did another one. If you double click on any of these users, you will go back to the user and you could see his own results. But that user is more interesting when it comes to the false exclusions. And I just zoom here on the graph, and you can see that he made a number of false exclusion. Again, the false exclusion, you see all the greens are people who correctly made an identification. These are the inconclusive. These are the no values in blue, and these are the cases of false exclusion. So as a relief, it may that user 20 may realize that he was not alone in that process. He's here, but he's among a series of examiners. And that reflects what Heidi mentioned before, is that there is quite a large amount of variations between examiners. So every examiner can go back to the study, look at their own results. And I just want to highlight this one, which is interesting. This is a case, the little stars indicate that the case was by majority declared different from the grand truth. And there is a number of these cases where the majority vote by the examiners differed from the grand truth conclusion. That examiner can download all the data. So if you click on download, it will download the data for user 20, and you can download all the data of the research to do your own statistical analysis if you'd like. And I'd like to show you the overall results. So we have done user by user. Now you bring all users together, and you could see exactly with the same convention, you can see their results. That's exactly what Heidi showed you in the different slides she went through, associated with the study overall. And if you click on the graph, and that will take a few seconds, probably more on the web application, it will show exactly the same type of images as before, but for the whole study. So you could zoom, explore one case of interest on the entire study altogether. So I hope it will come back, but it should. And these graphs give a complete overview of the case. What we already know is that there is a large amount of variation between examiners depending on the case. Some cases may be voted differently. All these little stars are cases that were voted of different sources because the majority decided to, whereas in fact, in truth, it was from the same source. So we have 6 cases that were of that kind, and you can zoom and go to explore further the data to see all the possibilities, all the distributions. It allows you to realize that in some cases, the case has been seen by a very limited number of examiners, and that allows also to realize the weight to be given to some deviation from ground truth. So this is the first application. We had a lot of pleasure to put it together. Feel free to use the quick tour panel to go to explore if you forgot or if I was completely obscure in my explanation or too quick. The second little application I'd like to show you is for confidence interval, and I will conclude on this. This is an app that we designed to answer the question of what is the upper bound or lower bound or confidence interval or credible interval associated with a given error rate. So we can look at the data user by user exactly as we did before, or we can look at the data for all users. So if I click on all users, I will have the same little matrices that you have seen in my presentation. And you can, of course, move from one to the other. So for the sake of the discussion, I'd like to show you how we use it for the false positive rate, which is the 12 wrong identification. And if you click on the box, it will immediately tell you the proportion. So this is the error rate, which you already have seen used in the study. Quite often, and you will see this is the case when you have a 3x3 matrix, it's difficult to know what has been used as a denominator. I mean, what is the total used? Here you can see, okay, the total is 12 plus 1773. And if you click here, it will tell you exactly how the proportion was computed. So how you get that number. You will see for 3x3 matrix, it's not that trivial. So you select a proportion, you have your proportion of interest, and the next question is, well, what is the confidence interval around that proportion? I use the term confidence interval loosely because, in fact, we have made computation according to 2 different schools of statistics. One is named frequentist, leading to confidence interval. The other one is named Bayesian, leading to credible interval. What we wanted to give to the user and to people using that interface is a quick comparison between these methods, because some statistician will put you in a corner if you use one method or the other. And in fact, you could see by looking at the upper bound, which is that point, the upper bound confidence interval is 0.01 for our error rate. And if you change the statistical method, it's 0.011. The difference is effective, it's a reality, but at the end of the day, it has no operational impact in our opinion. You can compute the confidence interval at 95% or at 99%. These two are the summary, but you can go into in more detail about how it has been computed. We have used 2 methods from the Bayesian side of the Bayesian approach in statistics, and we have used a large number of frequentist techniques that have been proposed in the statistical literature. The purpose, and you can see the one with little arrow, the little stars, is the one that we have selected for the summary. The purpose of this is to show that there is no need to die on selection of the technique when you have a lot of data. You will not see a lot of differences between all these intervals when you have a study with a lot of data. It will change if you go on a user-by-user basis, and that will become more tricky, the good choice of the technique. But when we are just interested in the confidence interval for the overall results, there is not much differences between all these techniques. I switch to another table for the analysis, and let's assume you'd like to have information about the number of cases where it was declared suitable for exclusion when the ground truth was different. And I just want to show you the proportion. So the proportion is the people who have declared a mark being suitable for exclusion only, where the majority said either no value or suitable for identification. So these decisions are labeled off the expected values, and that give us this proportion. And this is the little difficulty, because quite often you don't know how that proportion was calculated, how this 2% was calculated. If you click here, it will show you exactly how it was calculated and what was summed up in order to get the proportion. And that will be valid for the false positive, for the false negative. You can compute the confidence intervals on any of the rates available in the study, either for all results or on a user by user basis. So if we go back to user number 20 and we look at his error rate and we want to compute the confidence interval on 0, and remember the fact that the proportion is 0 does not mean that the upper bound will be 0, and you look at the confidence interval obtained, and you will obtain the upper bound. And you will probably be terrified by the numbers that you get, because with 0 error, the upper bound reach 16% for the frequentist techniques and 13% for Bayesian techniques, which are these two numbers. The reason why they are so high is because we have so limited number of tests. Because it's 0 over 21, it's a very good proficiency testing result. But when it comes to do statistics on this, of course, the number of cases is so low that we have to allow for large bound to cover the true value if I refer to the credible interval. Hence, our general argument is that this app, you can compute your own user by user error rates. We doubt that these error rates have any meaning in direct sense. We believe that the ones which are most effective to discuss the issues are when we focus on the results combined by all the users. So a general profession error rate instead of talking about individual error rates, because individually every user hasn't done enough tests in order to obtain very small confidence interval. The people who have a statistical mind may want to go further, and one way to go further is to change the prior. If you take the quick tour, it will be explained how to use this interface, but this is a statistical complexity which is not required for this presentation. That ends what I wanted to show you. I go back to the app, and feel free to go on this app, explore the results, come back to us if you have any questions regarding them, and we'll be very happy to answer, as we are available to answer any of your questions in the forum. And this is the last slide to thank all our donors and laboratories who participated with us in that study. I feel alone. Oh, thank you, Josh.
Thank you so much, Christoph, and thank you, Heidi, as well. We do have quite a few questions that came in. We've only got about 10 minutes, so we'll jump in momentarily. I just want to let all of our audience know that we are recording today's event. We will be converting that into our archival version into the next few days. Should you want to refer back to today's webinar, or you have any colleagues that might have missed today's live event, we also have a PDF version of today's slides that will be back on the main page where you first entered in today's webinar. You will be able to download those directly before you leave today. So Heidi, the first question came in towards the beginning of your presentation. Amanda was asking, how was it determined what constituted a quote-unquote close non-match?
Haha. Okay, that's a $1 million question. So we have a whole different research project that's focused on that. But basically, we did it through, as I said, the APHIS process. So we put those into APHIS, and we had two different designations of close non-match. One was the number one APHIS candidate, and the other was one that was selected by our research assistant, and it was just a judgment call where they looked at it and selected the one that looked the closest to them. And we used both kinds in the study.
All right, we'll throw the next question. Christoph, we'll throw this your way. If we were not part of this black box study, can we still examine the results through this app?
Yes, absolutely. Everybody can access to the app. They will see all the users, everything I showed you is available to anyone.
All right, Heidi, another one coming your way.
Okay.
Justin's asking, what was the criteria for participation in the study? Was there a correlation between experience and training levels to erroneous identifications?
Okay, so people were self-selected. We recruited pretty broadly, and we asked only that they be a latent print examiner of some flavor. They could be retired, they could be a supervisor who used to be, they could be active. We even allowed trainees, but we had a demographic question where people had to tell us if they were a trainee. So we were able to look at their data separately, and none of the trainees made any of the false positive errors. As far as the second half of your question about whether there was any correlation between experience and errors, there was not. We didn't see any correlation between any of the demographic questions and any of the accuracy outcomes.
All right, thank you, Heidi. Next question, Christoph, kind of a two-parter. Were all the participants latent examiners? And if not, what was the experience of each examiner?
Oh, sorry, could you repeat the question, Josh?
What were the participants, were all the participants latent examiners? And if not, what was the overall experience of each examiner?
So, yes, Heidi mentioned that. We had examiners with various level of experience, and the initial questionnaire that we asked examiners, they were invited to tell us their latent print status, whether they were accredited or not, or certified or not, whether the number of years of experience they were involved in the job, the number of times they went to court, and so on and so forth. So we have a variety of examiners that took the study. They not have been selected for a given number of years of activity.
All right, Heidi, next question is for you. What criteria was used to rate difficulty? Was there a quality matrix used, minutia count, amount of distortion, etc.?
Right. Okay. So this was done a couple of different ways. When we're talking about just the quality of the mark on its own, that is the part that Christoph was referring to, where he ran those quality metrics to measure the quality of the image. And so we were able to use the scores for that when he was doing his machine learning to see whether we could predict outcomes, analysis decisions based on the quality of the image. That's one piece. When we talked about the difficulty of the comparison, those were set by me, and they were done fairly arbitrarily. Basically, I had to do every single comparison before we put it into the study, because if it was the same source ID, we wanted to make sure that the information that the participant needed in order to make the ID was actually present. In other words, if it came from the same source, but the same area wasn't recorded or wasn't sufficiently recorded in both images, it's not a fair same source trial. So I went through and did every one of those comparisons before we put them into the study. And during that process, I ranked the difficulty, and the difficulty had to do with sort of how long it took to find, how clear it was, how much information there was in common between the two, how clear that was, and also if it was oriented correctly or not. Sometimes I would, turn them upside down to make it a little harder to find. Sometimes I had 3 exemplars for every mark. So sometimes I would pick the more degraded exemplar to make it a little bit harder. And then I also had sort of a rule for myself where if I did the comparison and it was, once I found it, it was easy, but it took me a long time to find it. I sort of moved it up a difficulty category. So in other words, if the side-by-side and oriented correctly, it might have been a medium, but it took me like half an hour to get onto the darn thing because it was so hard to find. I would bump it up to a hard, if that makes sense.
All right. We'll give everyone just a couple of minutes before the top of the hour to submit any last questions before we do wrap up today's event. But while we're waiting on any questions to come in before wrapping up, again, we do have a PDF version of today's slides that are back on the main event page. Make sure you do download those before you leave today. Also, we have recorded today's webinar, and we'll be converting it into our archival version over the next few days that you'll be able to refer back to or, again, pass along to any colleagues that might have missed today's live event. We do have about 2 minutes before we wrap up. I would like to give our presenters just a last minute plug before we do close out today's webinar. So Heidi, I'm going to throw the microphone back over to you just to give us some kind of closing thoughts and where you see your study and research going over the next few years.
Oh, okay. So we have a couple of other projects in the works right now, actually. One of them is, as I mentioned earlier, working on close non-matches. It's something we're really excited about. We're trying to build a database of known ground truth close non-matches. And to tie into the earlier question about how do you know it's a close non-match, we have a group of experts assembled, and we are actually going out and actively seeking close non-matches in databases all over the world. And once we've put together this group of known ground truth items, we're going to make them available to many law enforcement agencies, and they'll be able to use those in their training materials, their proficiency tests, etc. So we're pretty excited about that one.
Thank you so much, Heidi. And Christoph, I'm not going to leave you out either. I'll put you on the spot, just if you have any closing words as well.
Well, my closing words will go to the examiners. First, I'd like to thank all the examiners, and I know some of them are probably listening, who participated to such studies. I mean, there is an element of transparency which is asked from all the profession nowadays, and without their support and commitment, we will not be able to have any clue about the state of affair. Now, the results can always be looked at from different angles. The positive angle from me is that my initial expectation was that we would have a much higher false positive rate. My fear with Palm is that there is less discriminative information, pattern force applying quite often in different areas, and I feared at some point that we will have much more number of false positive. The false negative rate is high. And we know, I mean, this is not a surprise. It just should give us some good argument to increase education, to put more efforts in Palm training in order that we don't miss that much, to put much more efforts also in technology to do the palm print searches and recognition, because algorithmic matchers are improving drastically in recent years. We knew that, yes, there is quite a high rate. It's a balance between the two. But overall, I hope that this study is giving some peace to people having fears about the proficiency of the profession as a whole. Now, when you look at examiners on an individual basis, we have observed indeed that it might be a different story. But as a globality, the numbers now are available, and they give a fair representation of the state of affair of the discipline.
All right, thank you so much, Christoph. We did have a last-minute question and comment come in, so we'll pose this right before we leave. So the comment that came in was from Kate, just thanking both of you for the information. She said it will be very useful in addition to her lectures about fingerprints for her forensic students. So definitely thank you both for that. And then the question coming from Justin was asking, could the participants look at each comparison once, or could they go back to them and review?
That depends on when they hit the submit button. So they had the ability to go in and out of their comparisons as many times as they wanted until they hit submit, and then it was locked. And they could still go look at it if they wanted, but they couldn't make any changes to their determinations at that point.
Yes, and every examiner could apply we didn't give them, apart from a deadline at some point, but they could take the time required to do the study.
Yes, we had the study open for several months, so it was definitely not a rushed thing where they had to get it all done in a weekend or anything like that.
All right, thank you both. And with that, we are going to go ahead and wrap up today's webinar. Obviously, the first thing we would like to do is thank both of our presenters today, Ms. Heidi Eldridge and Mr. Christophe Champeau. We are going to go ahead and again close out our webinar. Thank you for everyone for attending today's webinar. These events are just simply not able without your participation. So thank you everyone for your attendance and your support today. Thank you for all of your interactive questions as well. You will find, as with all of our other webinars, a link to our short survey that will be directly below our closed captioning pod on the bottom right. If you could take a few minutes before you do leave out of today's webinar to go through our customer satisfaction survey, we want to make sure that we are providing you the best webinar experience, as well as adjust any content and the way that we disseminate that information out to you, our audience. That feedback that you provide is vital information that we always make sure to use. So if you could take a few moments to complete that survey, we would definitely appreciate it. Also, you will see coming through the chat pod momentarily, Tyler will be placing links to our social media outlets, Facebook, LinkedIn, and Twitter, where you can follow all of our social media posts that we are constantly updating. He'll also be putting links to our podcast, which is going into its 9th season, as well as link to our website where you'll find all of our no-cost webinars, events, success stories, as well as reports that we're constantly putting out. Again, thank you everyone for attending today's event. We hope you found it very useful. If you could take a few moments to complete our survey, we would greatly appreciate it. We're constantly adding new content to our websites, and we hope to see you again in our next webinar. Thank you everyone, and we hope you have a great rest of your day.
Bye. Okay, is that all?
Yep, that is it. I am closing things up on the user side.
I was expecting more questions. I feared when we had 10 minutes, I said, oh my God, I spoke too much and we'll have no question. We'll have no time for the questions.
Yeah.
I thought you both did fantastic. We actually had over 200 that joined today. I can get you the raw data in a bit, but in a couple of days probably would be best. But yeah, over 200, over 330 registered, so fantastic turnout.
Great.
It's bizarre because we